Welcome to Chapter 6 Test Review. Thanks for joining me. This is a quick outlook of the problems that I'm going to work through. In Part 1, we're going to get through numbers 1 through 6. Numbers 1 and 2, we're going to simplify the radical expressions. In 3, we're going to add and subtract. 4 and 5, we're going to rationalize a binomial denominator. And in number 6, we're going to rationalize a single term denominator. So if any of these problems look good to you, let's continue. Beginning here with number 1, we are going to simplify a square root expression. The square root of 400 x squared y to the 6th. The first thing that I'm going to do is tackle the number. Let's factor tree out 400. I'm going to break it into 4 times 100. The 4 breaks down to 2 times 2 and 100 into 10 times 10. I'm going to cross off the numbers that I've factored. And I'm going to stop my factor tree here. Because it's a square root, I'm looking for groups of 2. So the minute that you come up with a pair, you can stop their factor tree. Like the pair of 10s, I don't have to continue on factoring them down. Anytime that I have a pair, I'm going to pull it to the outside of the radical. What you pull out is how many pairs you have. I have a single pair of 2s, so I pull out a single 2. I have a single pair of 10s, so I'm going to pull out a 10. And anything that you pull to the outside, you multiply together. So let's look at our x's. X squared, that's 2. That's 1 pair, so I'm going to pull out 1x. Y to the 6th, that's 6 y's. I'm going to circle the pairs. I have 1, 2, 3 pairs. So I'm going to take out a y cubed because I have 3 different pairs. And as I look back at my problem, everything's either crossed off or circled, so there's nothing left inside the radical. I'm going to rewrite my answer so it looks nicer. Multiply the 2 and 10, it's 20x y cubed. Sometimes when you simplify, everything gets pulled out and you have a single answer. Moving on to number 2. This time, I'm looking for groups of 4. Whatever your root is, that's how many you're looking for in a group to circle and pull out. So this time, it's groups of 4. So, sorry. Let's factor tree that 81. I'm going to break it into 9 times 9. I can't stop with 9 times 9 because I'm not looking for a pair. I need to continue on until I have 4 of the same term or same number. Cross off the ones I factored. I have a group of 4 right here. So I'm going to pull the 3, 1 pair or 1 group of 3s to the outside. Let's look at our x's. I had 5 of them. I'm looking for a group of 4, so I circle the 4. That's what I pull to the outside, leaving 1 in. Same thing now with y to the 9th. I wrote out 9 of them. I'm looking for groups of 4. So 1, 2, 3, 4. 1, 2, 3, 4, leaving me with 1 left over. I have 2 groups, so I need to pull out y squared, representing the 2, and leaving me with 1 on the inside. Let me rewrite the answer. 3x y squared square root of xy. Let's work a problem now where we get to add and subtract together. I can't add and subtract it exactly the way it looks. The only way that you can combine different radicals is if the radicand, this part on the inside, is exactly the same. So I can't add it the way it is, but I can factor tree and see if I can factor it down to where it has a radicand of 7. So I'm going to go ahead and push pause and factor tree it out. This is what I got when I factored. I'm going to cross off the numbers that I've already used. So I can see that I've got a pair of 3's. Let me pull it to the outside, leaving this 7 inside the radical. And there's my 3. In the middle term, I have a pair of 2's. I used the 4 and the 28, so let's cross them off. And I have a 7 left over. So there's my 2, radical 7. The problem originally started with a 2 on the outside, so I need to bring it down to the next step. And anything together within a term on the outside, I'm going to multiply. So this becomes 3 radical 7 plus 4 radical 7. Bring down the original minus 5 radical 7. All my radicands are now the same, so I can add and subtract. And when you do that, you add and subtract the outside numbers. So I'll take 3 plus 4 minus 5, which is equal to 7 minus 5, 2 radical 7. At this point, when you add and subtract radicals, it's the exact same way that you would use with any variable. If you had 3x plus 4x minus 5x, you add and subtract it the same way. Your final answer, 2 radical 7. Moving on to the next problem, let's work a division where you have to rationalize a binomial that has a radical in it. To do this, we're going to multiply by the conjugate of the denominator. A conjugate is where you use the exact same terms, 1 and radical 2. Instead of a plus sign, we're going to use a minus. When you're multiplying by the conjugate, it has to be a plus and a minus. And whatever I multiply by the denominator, I do the same thing to the numerator. So let's look. Let me move these really quick. There we go. Let's look at the numerator. I'm going to distribute the 2. 2 times 1 and 2 times negative radical 2. Remember, the 2's can't multiply together. It's 2 radical 2. Going now to the denominator, I have 1 times 1. I have 1 times negative radical 2. I have positive radical 2 times 1. In my last term, I have positive radical 2 times negative radical 2. So a positive and a negative makes it negative. And when you're multiplying radicals, you do bring the numbers together. So I have a pair of 2's here. You can pull out, or think of it as 2 times 2 is 4, and the square root of 4 is 2. You lose the radical altogether, and that will always happen. If you are multiplying radicals that are the exact same numbers, if it's a square root and it's the exact same number, the square root drops out. So let's write this a little bit nicer. Here's my numerator, 2 minus 2 radical 2. In my denominator, I have the 1. The two middle terms, it's a negative radical 2 and a positive, so they cancel, leaving me with minus 2. And 1 minus 2 is negative 1. So 2 minus 2 radical 2 over negative 1. Let's go ahead and divide. 2 by negative 1 is negative 2. And negative 2 over negative 1 is positive. And that is your final answer. We're going to do this one more time in the next example, where you have a binomial in both the numerator and the denominator. I still want to multiply by the conjugate of the denominator. It's all about the denominator. Use the exact same terms, 6 and radical 5. They gave me a minus, so I'm going to make it plus. Conjugates. It's always the opposite sign of what you're given. And what you do to the denominator, you also do to the numerator. And the laws of math are satisfied. All right, I'm going to show this in a slightly different method. I'm going to write it out FOIL. Again, if you're a very visual person, you might like the FOIL method. Oops, except it's FOIL. So let's FOIL out for the numerator. First to first, 7 times 6, 42. 7 times radical 5. Radical 5 times 6. And radical 5 times radical 5. And this is what I talked about in the last example. It's a square root with the exact same number. I can get rid of the radical, and it's 5. Bringing them together, my numerator, I have 42 plus 5, because it's positive. 7 plus 6, because they're both positive. 13 radical 5. Let's do this now for the denominator. Write out my FOIL. 6 times 6 is 36. The outside would be positive 6 radical 5. The inside, there's that negative 6 radical 5. And last to last, it's negative and positive. So negative times a positive is negative. And I have the exact same radicals, 5 and 5, so it's minus 5. 36 minus 5 is 31. And the middle terms is 6 minus 6, and they cancel. So bring your whole answer together. Numerator, 47 plus 13 radical 5. Denominator is 31. So when you're working these problems on your test, you can write it out, FOIL. Make sure you do it for both the numerator and the denominator, if that makes it better for you. Our last problem for this portion is not quite as intense. I need to rationalize my denominator, but I only have one term. So I look here, and I see a cube root. That means I'm looking for groups of 3. So I'm going to extend out the radical. I have a 2. If I want groups of 3, that means I need 2 more. And if I put them in the denominator, I also put them in the numerator. I'm going to go ahead and start my answer. I had my group of 2s, or my group of 3 there, so I'll pull it to the outside. I have an x, and I need a group of 3, so I'm going to put 2 more in, and then I also put them in the numerator. So I have 3 x's, and I can pull them out, but they have to stay in the denominator. So when you set up your answer, make sure you set it up. You have a numerator and a denominator. Before I finish this out, I know with the 4, I can break it into 2 times 2. And I'm going to do that because I need a group of 3. Right here, I have 3 2's. So I can pull this group of 3 out. And it's in the numerator, leaving me with 2x squared on the inside. And in my last step, 2 over 2 can cancel. And my final answer is the cube root of 2x squared all over, just x. And the x's can't cancel because one of them's under the radical and one of them is not. And that concludes part 1 of Chapter 6 Test Review.